These are the examples from Lesson R.8, Linear, Compound, and Absolute Value Inequalities. Example 1. Solve the inequality negative 5t minus 6 is greater than or equal to negative 24. Alright, to solve for t, we're going to start by adding this 6 over to the other side over here. These are going to cancel out. Over here on the left, we're left with negative 5t. This is still greater than or equal to, and then 6 minus 24 is going to give me negative 18. Alright, still solving for t, we're going to divide by a negative 5. Now when I divide by a negative number, my sign has to change around in the other direction. So in my next step, I'm going to turn it around. Alright, these are going to cancel. We're left with t. This is now less than or equal to, and over here, the two negatives will cancel out, so we're going to have a positive 18 divided by 5. Okay, now let's talk about how to write the solution sets. If we look at the picture, we have a number line, and we have 18.5 here, or 18 divided by 5. Alright, a number smaller than 18 divided by 5 would be 17 divided by 5. And a number bigger than 18 divided by 5 would be 19 divided by 5. Okay, when we draw the graph, we're going to put a closed circle around 18 divided by 5, and that's all because of the little equal to down here in the less than or equal to sign. And we're going to shade the number line to the left. Alright, now if I'm going to write this in set builder notation, this is the one with the braces. Alright, we have the set of, our variable is t, such that, and now we need our rule, which conveniently is located right here. We just solved the problem. So t is less than or equal to 18 divided by 5. When we do our interval notation, these are the ones that look like ordered pairs, and they're either enclosed in parentheses or brackets, or one of each. Okay? Alright, so to do your interval notation, you look at your graph, and the number that's included in your graph that's the most to the left. Now here, since we've shaded in the arrow here, indicating it's moving on to negative infinity, that means our number most to the left is going to be negative infinity, comma, and then the number that goes on the right is, we look back up here at our picture, and the number that's included that's the most to the right, well, the graph stops right here at 18 over 5. And now we decide on how to enclose them. Now infinity will always be getting a parentheses, and the 18 over 5 is going to get a bracket because it had a closed circle on the graph, and that was all because of the equal to over here in the less than or equal to. For example 2, we're going to solve the equation m minus 4 divided by 2 minus 3m plus 4 divided by 10 is greater than negative 3m divided by 5. Alright, because this problem has fractions in it, let's see if we can clear out those fractions. Now, my denominators are all 2, 10, and 5. So the least common denominator would be a number that 10, 2, and 5 can all go into. The smallest one they can all go into is actually 10. Alright, so what I'm going to do is I'm going to multiply each of these fractions individually by the 10, and then I'm going to cancel, and what I'm left with will be an inequality that has no fractions in it. Okay, so we're going to take m minus 4 divided by 2, and I'm going to multiply it by the least common denominator, minus the 3m plus 4 divided by 10, and I'm going to multiply it by the least common denominator, greater than negative 3m over 5 times that least common denominator. Okay, and then remember what I'm going to do is I'm going to look at each of these individual sets of fractions, each individual pair, and I'm going to cancel what I can. So if we look at these first two, 2 can go into 10 5 times. That means I'm left with an m minus 4 times 5. Okay, minus, when I look at my second pair here, these 10s will cancel each other out. That's going to leave me with a 1. So we're just going to have a minus 3m plus 4 here. And I need the parentheses around this because that negative is going to have to be distributed to both of my terms here in the polynomial. All right, greater than. Now we're looking at my last pair. We've got 5 goes into 10 2 times, and I'm left with negative 3 times 2 over here, negative 3m times 2. All right, let's distribute. I'm going to distribute the 5 in the parentheses. That gives me 5m minus 20. And I'm going to distribute the negative into the parentheses. That's going to give me negative 3m minus 4. And this will be greater than, and I can just multiply these two. That's going to give me negative 6m. All right, over here on the left, let's add our like terms. 5m minus 3m leaves me with 2m. And then negative 20 minus 4 is going to give me negative 24. And this is all greater than negative 6m. Okay. So my m's are already over here alone. I know it's negative. We'll take care of that in a minute. Let's subtract the 2m to the other side with the 6. All right, over here on the left, we know these are going to cancel, so we're left with a negative 24, which is greater than, and then negative 6 minus 2 is going to give us a negative 8. To solve for m, we'll divide by negative 8 on both sides, and since I'm dividing by a negative number, I want to remember to turn the sign around in the other direction. So 8 goes into 24 3 times, and 3 is going to be less than m. Well, if 3 is less than m, then it must be true that m is greater than 3. Now, I can write my solution sets. So let's take a look at the picture first. All right, we'll put 3 here. And then over here, 2 is less than 3. And over here, 4 is greater than 3. We're going to put an open circle on the 3, and that's because it's a greater than sign. It's not a greater than or equal to. And then we want all the numbers greater than 3, so we're going to be shading our graph to the right, all the way out here to the arrow. All right, for our set builder notation, we want the set of, our variable is m, such that, and then our rule, right here it is, m is greater than 3. Or you can use the 3 is less than m if you want to. Either one's going to be okay. When you write your interval notation, right, the number furthest to the left on the graph is the 3. The number furthest to the right on the graph, well, I've shaded my arrow, so that's going to be positive infinity. And now we put a parentheses around the 3 because it had an open circle. And then infinity will always have a parentheses on it. For example 3, we're going to solve the compound inequality 1/4 times y is less than negative 1, or 3 plus y is greater than or equal to 5. Okay, so what we're going to do is we're going to solve each one of these inequalities individually, and then we're going to graph them and determine where the solution set occurs. Now, for OR problems, all right, we are looking for the place, or any place, where your graph has been shaded. Anything on the graph that's been shaded is going to be part of your solution set. All right, so let's consider the inequality 1/4 times y is less than negative 1. All right, I immediately notice that I have a fraction in here. So what I'm going to do is I'm going to multiply this whole inequality by 4, and that's going to clear out my fraction here. So 1/4 times 4 is going to leave me with 1, or just plain old y. And on the other side, -1 times 4 is going to give me a -4. So when I graph this thing, I'm just going to change colors here for a second. All right. Draw my number line. And let's see, I'm going to put a -4 on the graph. And let's see, we can put a -5 on this side and a -3 on this side. Okay. Now we're going to put a circle around the -4, and that's because it is less than, it is not a less than or equal to, okay? And we want to shade everything to the left for there, so that means we're going to shade everything back here, including the arrow. Alright, so there's the graph of y is less than -4. Now, we'll come over to the other side and we'll concentrate on the 3 plus y is greater than or equal to 5. We'll subtract the 3 to the other side. These are going to cancel. This leaves me with y is greater than or equal to +2. All right. So now we're going to graph this. I'm going to put it on the same number line. All right. So we can put +2 out here, and then 3 is bigger than +2, and of course 1 is smaller than +2. And I'm going to put the graph up above here. It'll fit on the same number line, but I'm just going to put it up above. 2 is actually going to have a closed circle, and that's all because of the equal to down here in the greater than or equal to. And then we're going to shade it to the right. So everything to the right of 2 is going to be included in the solution set. All right. So now it's time to write my solution set. Now, in set builder notation, remember, anywhere that the graph has color on it that's been shaded is going to be included in my solution set. That means all of the pink area is part of my solution set, and so is all of the green area. All right, so when I write my solution set, we have the set of y such that, all right, and in my rule, I'm going to have 2 of them because I have 2 separate pieces of graph. I have a pink part and a green part. So the pink part says that y is less than -4, or the green part here, y is greater than or equal to +2. When I do my interval notation, I'm going to have 2 intervals because I have 2 separate pieces of graph. So I'm going to have to write an interval for the pink part of the graph, and then I'm going to have to come over here and write an interval for the green part of the graph. Okay, so let's do the pink one first. The number on the pink graph, the most to the left, we would say is -infinity. Still on the pink graph, it goes all the way up to -4. All right, -4 is going to get a parentheses because it has an open circle, and infinity always gets a parentheses. All right, now let's do the green one. On the green graph, the number that's included most to the left is +2. And then on the green graph, furthest to the right, well, we shaded the arrow, so that's going to be +infinity. All right, the 2 is actually going to get a bracket on it because it was a closed circle. And then infinity is going to get a parentheses. And the last thing I'm going to do is I'm going to put my little union symbol in here. It's just a U, okay? And that indicates that there are 2 places where I can look on my number line to find my solutions. I can look here, or I can look here. And we read that symbol as an or. For example 4, we're going to solve the compound inequality 0.36w is less than or equal to 0.54, and -1/2w is greater than +3. Okay, so once again, what I'm going to do is I'm going to solve each of my individual inequalities, and then I'm going to put them on the number line. Now, for these AND problems, when I'm looking at my graph, I want to know where the graph has been shaded for each of my inequalities. So it has to be here and here. And what I'm looking for on the graph is, where do the two graphs cross each other? Where do they overlap? That's going to be my solution set. All right, so let's look at this first inequality here. We're going to solve for W. Let's divide out the 0.36 on both sides. These are going to cancel. We have W is less than or equal to 3 over 2. All right, now if we want to graph that, we can put 3 over 2 on our graph here. Less than 3 over 2 we know is 1, which is 2 over 2. Greater than 3 over 2 is 4 over 2, but that's just 2. Okay? All right, and to graph it, we are going to put a closed circle here at 3/2, and we are going to shade this graph to the left, including the arrow, because the solution set includes all the numbers that are less than or equal to 3/2. All right. Now, we'll go over and we'll work on the other side here. I have a fraction, so I'm going to actually multiply both sides by 2, actually by -2, because I want this W to be a positive instead of a negative. Okay, so we have 2 times -1/2 W greater than 3. And because I'm multiplying by a negative number, I want to be sure and turn that sign around in the next step. All right, so 2 times -1/2, that's 1. We have 1 W. Turning the sign around, -2 times 3 is -6. All right, so over on the graph, we can put our -6 back here. And let's see, -7 is smaller, and -5 is larger than that. All right, and let's see what the picture is going to look like now. We need to have an open circle on the -6, because that's just less than, it's not less than or equal to. And less than means we want to shade everything to the left. It's going to be all of this, including the arrow we would be shading in. All right. Now our solution set, because this was an and, all the places on the graph that, or the graph overlap. So back here, there's no graph at all. Then I get to the blue graph, blue graph, blue graph, blue graph, blue graph. Oh, when I get right here, I've got blue and orange graph. And I've got it for the rest of the time on the number line there. So my overlapping area is going to be from here on. All right, so for the set builder notation, this one's going to look a little bit different, because before we had said, oh, look, conveniently, the rule is located right here. Well, when we look at the graph up here, we can tell where it's been shaded twice, and that's what our rule is going to be. We want the set of W such that the double graph starts right here at -6, and it's everything to the left of -6. So we want everything that is less than -6. Now, it's just less than, not less than or equal to, because even though -6 is included right here in this part of the graph, it is not included in the orange graph, so it will not be included in my solution set. Remember, because it has to be on the blue graph and on the orange graph. All right, When we go to write our interval notation, again, we're doing it for just the overlapping graphs. To the left, well, both of the arrows have been shaded, so that's going to be negative infinity. To the right, we go all the way out to -6. And remember, it's included in one but not the other, so it's going to get a parentheses. If this were shaded in, we would put a bracket on the 6. But it's not, so it gets a parentheses. And then infinity always gets a parentheses. And there's our solution set. Alright, for example 5, we have something called a three-part compound inequality. And there are two ways to solve this. Okay, and I'm going to show you the short way, and then I'm going to tell you how to do it the other way if you want to do it. Alright, now the short way here is, you'll notice my variable's in the middle. And if this were not here, we would know exactly what to do. Or, conversely, if this were not here, then we would know how to solve this problem. Well, we know we want to isolate the y, and I know I'm going to have to add the 4. And the question is, where do I add the 4? And the answer is, you're going to add it in both places, because we have two inequalities going on, and I know that because I have two inequality signs. So if I'm going to cancel out that 4, I'm going to add it here and here. Okay, so -16 plus 4, this is going to give me -12, less than or equal to, the 4's are going to cancel, we've got a -3y here, and then 2 plus 4 over here is going to give me a 6. Alright, still trying to get y by itself. I'm going to divide by a -3. I'm going to divide by a -3 here, turn that sign around, and I'm going to be dividing by a -3 here, turning that sign around. That's going to give me a +4 greater than or equal to y greater than -2. All right, let's look at the picture of it. On the graph, I'll have a -2. I'm going to have a +4. The -2 has a greater than, not a greater than or equal to, so we're going to put an open circle on the 2. The 4 has a greater than or equal to, so that means we're going to have a closed circle on this one. And then the graph, where do I shade it? Well, over here in the inequality, I notice that y is located in the middle, and that means that I'm going to be shading my graph right here in the middle. For my set builder notation, I have the set of y such that, and conveniently, my rule is located right here. So we have 4 is greater than or equal to y, which is greater than -2. And then when we go to write the interval notation, the number furthest to the left is -2. Furthest to the right on the graph is +4. The -2 has an open circle, it gets a parentheses, and the +4 has a closed circle, it gets a bracket. Alright, the other way to solve this three-part compound inequality is to actually separate it into its two inequalities that went together to combine into this. Alright, the first one is -16 is less than or equal to -3y minus 4. And the other inequality is -3y minus 4 is less than +2. And then there's actually a word that goes here in between, and that word is and. So this means that when we graph it, we're going to be looking for the overlap between the two graphs. All right, concentrating over here, we can add 4 to both sides. This is going to give me -12 is less than or equal to -3y. And then I can divide this side by -3 and divide this side by -3, but when I divide by a negative, you want to be sure and turn that sign around. So now we know that 4 is greater than or equal to positive y, which means that y is actually less than or equal to 4. Okay, let's see what that picture is going to look like. Okay, so we can put 4 on the graph back here. Of course, we know 5 is bigger, and 3 would be a number that is actually smaller. We are going to put a closed circle on the 4 because of that less than or equal to, and we're going to shade to the left because we want all the numbers that are less than positive 4. Alright, now let's take a look at the other graph. We'll add 4 to the other side. This is going to leave me with -3y equal to 6. No, less than 6, sorry. When I divide by the -3, I want to be sure and turn the sign around in the other direction, so we have y is greater than -2. Alright, now let's add that graph over here. So we can put -2 back here, -1 goes on this side, -3 goes on this side. -2 is actually going to get an open circle because it's just greater than, it's not greater than or equal to, and we are going to shade this one to the right because we're supposed to shade all the numbers that are greater than -2. Okay, and we're shading in the arrow as well. Remember, for these problems that are connected by the word and, we want to know where the two graphs overlap each other. Where on the number line do I see two graphs? Well, starting back here, I've got purple graph, purple graph, purple graph, purple graph. Oh, here's some orange. So we got orange and purple, orange and purple, orange and purple, orange and purple, up to this point, and then it's just orange, 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 orange. So the two graphs overlap one another between here and here. Now, in our set builder notation, we have the set of y such that, and we want to look at the graph and determine where y is located. Now, y is in the middle, right here in between -2 and +4. So y is between -2 and +4. And because the -2 has an open circle, we know this is going to be less than. And because the +4 has a closed circle, we're looking at a less than or equal to here. And then for the interval notation, the number the furthest to the left of my double graphs is -2, and the number furthest to right of my double graphs is +4. And since -2 has an open circle here, it's not included in both. Remember, it has to be on the orange and on the purple. It's going to get a parentheses. And since 4 does have a closed circle, it is here and it is here, it's going to get a bracket.